Problems on theorems on probability. And that first problem is, if two dice are thrown, what is the probability that the sum is, first problem, greater than 8, second one, the sum is neither 7 nor 11, third problem is an even number on the first die or a total of 8. So to solve this problem, first we concentrate on what are the exhaustive cases in this problem. So to find the exhaustive cases means the number of possibilities of this experiment. Simply it is sample space of this experiment. Here the experiment is dice experiment. So if two dice are thrown, the number of possibilities are, that is the first step of the solution. If two dice are thrown, the number of outcomes means possibilities, is the number of possibilities is equals to n of s. What is the meaning of n of s? Cardinal number of s means sample space. So n of s is equals to 6 square. If one die is thrown, the number of outcomes or the number of possibilities are 6 power 1 is equals to 6. All of you know a die has 6 faces, each face having the number 1, 2, 3, 4, 5 and 6. Okay, this is the possibilities of one dice are thrown. If two dice are thrown, the number of possibilities are 6 square. If three dice are thrown, the number of possibilities are 6 cube, like that. Okay. So here 6 square is equals to the number of possibilities are 36. Number of possibilities are 36. So in 36, I am going to write 6 outcomes. I am going to write 6 outcomes out of 36 like this: 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Look at these outcomes. Here each outcome represented as an ordered pair. Is it? So in this ordered pair, first element belongs to the number on the first die. Second element belongs to the number on the second die. That means first element represent the number on the first die, second element represent the number on the second die. Like that, in the second ordered pair, 1 is the number on the first die, 2 is the number on the second die. So like this, we will also going to write the remaining outcomes like that with 2. Here with 1 we write all outcomes up to 6. With 2 as first element of the ordered pair, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6, and so on. 6, 1, 6, 2, and so on. 6, 6. So these all outcomes are 36. Okay, so this is the possible outcomes when 2 dice are thrown, 36 outcomes. So this is the exhaustive case of this experiment. So exhaustive cases is vary from experiment to experiment. So what are the exhaustive cases? If 1 die is thrown, that is 6 exhaustive outcomes, means 6 exhaustive elements or events. If 3 dice are thrown, then the number of exhaustive cases are 6 cubed. Exhaustive cases means the number of elements in the sample space. That is the notation n of s. Okay. So in this problem, first subproblem is the sum is greater than 8. How we are going to find the sum, the probability that the sum is greater than 8. So to find this first subproblem, we need to write all outcomes which is the sum greater than 8. Look at the all ordered pairs, means all elements in the set capital A. 3, 6. 3 plus 6 is greater than 8. 6 plus 3 means 9, it is always greater than 8. 4 plus 5, 9, always greater than 8, like this. So observe the each ordered pair in this set capital A, the sum of these two elements, the sum of two elements means the first number on the first element of the first element represent the number on the first die, the second element represent the number on the second die. So the sum of these elements should be greater than 8. So such type of outcomes we are going to write in the first problem. So to write that ordered pairs, means that elements, we are going to take an event. That event name is A. Let A be the event. Let A be the event getting the sum of the numbers greater than 8. So this is A is the event, the sum of the numbers greater than 8. So how many events are there? How many numbers? How many elements are there which is the sum is greater than 8? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total 10 outcomes whose numbers sum is greater than 8. So n of A, clearly we are going to write n of A equals to 10. Okay. So now we are going to write the probability formula. What is the probability formula for the event capital A? P of A equals to n of A by n of S. This is the formula for probability of an event A. N of A means number of favorable elements to occur to an event A by total number of elements in the experiment. Means number of elements in the sample space. So n of A value already here, that is 10 by n of S means exhaustive cases in this experiment is Already we have the value in the first step, that is 36. This is P of A value. So this P of A represents the probability that the sum is greater than 8 is 10 by 36. This is the first problem. Now going to second problem. The sum is neither 7 nor 11. So to find this probability of the sum is neither 7 nor 11. That means we are going to find probability of A bar intersection B bar. This is the value we are going to find in the second problem. This means probability of neither A nor B. Probability of neither A nor B. So to apply this problem to this formula, here A is 7, B is 11. So to find the value of this problem, we are going to construct two events. That is, first event is capital A. So capital A be the event of getting the sum is 7. So that is A equals to 2, 5. Observe each number sum in the outcome is exactly 7. So such type of outcomes we need to write in the event capital A. So n of A equals to how many outcomes are here? 1, 2, 3, 4, 5, 6. That's why n of A equals to 6. Now we are going to find probability of A. Probability of an event A in this experiment is n of A by n of S. That is equals to n of A value is 6 here. 6 by n of S value, exact number of cases in the experiment is 36. Now we are going to construct another event here to the sum is 11. So now we are going to write, let B be the event of getting the sum is 11. So that is B equals to we are going to write all outcomes in the event B, which the numbers of sum is 11. So 5 plus 6, 11, 6 plus 5, 11. So number of elements in B is 2. Now we are going to write probability of this event B is n of B by n of S. N of B value is 2 here, 2 by 36. Okay. These are all elementary parts to find the required probability in this problem. So what is required probability? What we are going to find the probability in this problem is P of means probability of neither 7 nor 11. So 7 means that is event A, 11 means that is an event B. Neither, that is equals to probability of A bar intersection B bar. Now we are going to write the De Morgan law. A bar intersection B bar equals to A union B whole bar. That's why we are going to write like that. That is also equals to probability of non-occurrence of A equals to 1 minus P of A. So by using this formula, we can write this formula as like this. So here we are going to apply addition theorem on probability. So P of A value 6 by 36, 2 by 36. A intersection B is mutually exclusive events, that's why P of